Have you ever really stopped to think about how this explainer you're watching is getting to you? I don't mean in some abstract, cloudy way. I mean its actual physical journey. We're going to trace that incredible path from a computer thousands of miles away right to the screen in front of you. Let's dive in. So yeah, let's just start with that big question. What physical path did this very explainer follow through the world to show up on your device? It's a wilder story than you probably think.
You know, a lot of us have this picture in our heads of a signal beaming up to a satellite and then beaming back down to our phone. It makes sense, right? But for something like 99% of all internet traffic, it's just not how it works at all.
The truth is way more incredible, and actually a lot closer to home. The internet is a very real, physical thing. It's a massive, sprawling web of cables lying in the freezing cold darkness at the bottom of the world's oceans.
Okay, so why not use satellites? I mean, they're already up there. Well, it really all boils down to one single problem that anyone who's ever played an online game will know all too well: lag. So get this, the satellites we'd use orbit about 22,000 miles above us. For a signal to get from a data center all the way up to that satellite, and then all the way back down to you, it has to travel a staggering 44,000 miles. That round trip creates a very noticeable delay, a latency, that just doesn't work for the kind of instant connection we've all come to expect online.
So, if our journey doesn't start by shooting up into space, where does it begin? Well, it starts right here on the ground, inside something called a data center. The data for this explainer started its life tucked away inside a massive building called a data center. And inside that building is an incredibly powerful computer, a server. The actual file is just sitting there on a solid-state drive, or an SSD. This is ground zero. And from that little SSD, the data enters the real backbone of the entire global internet, what you could call a web of glass.
And this is where it gets really amazing. Your data, this explainer, gets converted into tiny pulses of light. And these pulses flash through strands of glass that are as thin as a human hair, all bundled inside these fiber optic cables, traveling at pretty much the speed of light. That's how information physically gets across continents and oceans.
And the engineering behind putting this network together is just mind-boggling. We are talking about over 800,000 miles of these cables crisscrossing the ocean floor. To build it, special ships sail out, drop a giant plow to the seafloor, and literally carve a trench for the cable to rest in, protecting it as it connects our entire world. It is a phenomenal feat of modern engineering.
Okay, so we've got this incredible physical highway system, but how does the data know which exit to take? Well, it needs an address, which brings us to the internet's own giant address book.
Every single device connected to the internet, from the server holding this explainer to the phone you might be holding in your hand right now, has a unique number called an IP address. It's exactly like a postal address for your house. It makes sure the mail, or in this case, the data, gets to exactly the right place.
But let's be honest. Who wants to remember a long string of numbers like 142.250.191.238? No one. So we use something way easier, a domain name, like youtube.com. It's basically a human-friendly nickname for that long, numerical IP address. So how does your browser connect that friendly name to the right string of numbers? It uses something called the DNS, or the Domain Name System. And you can think of it just like a giant digital phone book for the entire internet. When you type in youtube.com, your browser asks the DNS, which looks it up and finds the right IP address to send your request to. Okay, so we have the physical path and we have the address. But here's another clever part. The data isn't sent all in one big chunk. Instead, the internet uses a much smarter method, the packet system. The data for this explainer is actually chopped up into thousands of little pieces called packets. Each packet is like a tiny digital envelope. It gets stamped with your IP address, a return address, and a number, so they know what order they go in. Then they all travel independently. Some might go through Paris, others through Chicago, taking whatever route is the fastest at that exact moment. When they all arrive, your device just uses the numbers to put them back together in the right order. And if one gets lost, no big deal. Your device just asks for it again. It's an unbelievably resilient system.
Now, with trillions of these little packets flying all over the world at any given second, you can imagine it could get pretty chaotic. So the internet needs rules to keep everything moving. Think of them as the rules of the road.
These rules are called protocols. They're the agreed-upon language of the internet. They define everything from how to chop up the data into those packets to how to slap the right addresses on them. They are literally the traffic laws that prevent total gridlock.
And who manages this whole global system of addresses? Well, that's a huge job. It's handled by a nonprofit organization called ICANN. You can think of them as the global librarians, making sure there are no duplicate IP addresses and that the whole domain name system works together perfectly.
And here we are at the very last step of the journey. After traveling thousands of miles as light, those packets hit your home router. Now, your laptop can't read pulses of light, so the router's job is to translate. It converts that light back into an electrical signal for an Ethernet cable or into electromagnetic waves, that's Wi-Fi, to reach your phone. This is that final leap from the huge global network right onto your screen.
So, when you really boil it all down, this is what the internet is. It isn't some abstract cloud floating in the sky. It's a real, physical network of computers and glass cables all working together because they speak the same set of digital rules.
And that's it. That's how this explainer reached you. A journey of light and logic, across land and under the sea, all happening in less than the blink of an eye. So maybe the next time you stream anything online, you'll think about that incredible, invisible journey that's making it all possible.